Okay, good. Hello again, everyone. This is the second part of day one for trimester 1.2. We'll be looking at graphing and finding domain and range or sets of numbers. And so now you start to see why we first have to learn about sets of numbers before we actually start working with domain and range. So we'll be working with domain and range and graphing. But before we do that, let's define what a relation is. A relation is a pairing of input values with output values. It can be shown as a set of ordered pairs x, y, a coordinate point, if you will. Okay, you're quite familiar with a coordinate point x, y, x before y, where x is an input and y is an output. The set of input values for a relation is called the domain. Okay, so we say x is the domain, and then the range is y. Easy way to remember that x before y, d before r. Okay, so domain and range, x and y. So let's take a look at these graphs here, and we'll try and find the domain and range of these graphs. So here, a person decides to go for a run, but must take breaks at certain points. The person's distance from the house is shown in the graph. Now, they don't give us how long the person ran and how far they ran, but we'll just assume that the time they ran a total of 60 minutes. So I'll say they ran a total of 60 minutes. And let's say here they ran a total distance of, I don't know, what would be good? So maybe 4 miles, be 15 miles, 15 minutes a mile. So let's say 4 miles. So let's say they ran a total distance of 4 miles. Oops, that doesn't quite look like 4. So let's say they ran a total distance of 4 miles. So let's interpret this graph here. So this person decides to go for a run, but must take breaks at certain points. So let's say, oh, well, here I said they're walking to a friend's house. So let's say they're running to a friend's. So somebody is running or walking to their friend's house from home. Okay, or they're running from home, however you want to look at it. Okay, so let's see here. Someone walks to see their friend. Okay, and so that can be represented as line 1 here. They're walking, so when they start from home, they travel at 0 distance and 0 time, but then they start to walk or run to see their friend. Okay, so that would be that line there. So they ran so many minutes and went so many miles. They continue to walk, but not as fast. And so you see that this line is not as steep as the other line. So that would be like line 2. And then they pick up the pace again because the line is steeper. So that would be like line 3. So this is walking or running, however you want to take a look at it. Then at 4, they take a break. So they take a break. Their distance hasn't gone anywhere. The distance stays the same. Then they walk back home. So their distance from home is decreasing. Okay, so the distance from home is decreasing. So that would be represented by line 5 there. Okay. And it's at a quick pace because the line is somewhat steep. They continue to walk back home, but at a slower pace. So notice here that the line is not as steep as line number 5, but the distance is decreasing, so they're walking back home. So that would be line 6. And then they pick up the pace again. They pick up the pace because the line is steeper. So the line is steeper. So that would be represented by line 7. And then they walk at a slower pace as the line is not as steep as line 7. So they're walking at a slower pace and then they make it back home. The distance is 0. So here, what will be our domain then? Okay, so our domain, my domain, if I write this in 2 ways. I can say x is less than or equal to 60 minutes and greater than or equal to 0. So that would be, so anywhere from 0 to 60 minutes, including 60 minutes, if this entire time represented 60 minutes. 60 minutes. In interval notation, I can write that so from 0, because we include 0, and then we include 60 as well. So that would be inequality in the interval notation. Well, what about the range then? So the range, well, it goes from anywhere, so y, or distance, so again, we'll say this is x and this is y. So y, let's say here this represented a total of 4 miles here, so y would be less than or equal to 4 miles that they walked from home, and greater than or equal to 0 miles. And then in interval notation, it will be anywhere from 0 to 4 miles, including 0 and including 4. So that's how we would write the domain and range for that relation, for that graph. Okay, remember, domain is x and range is y. Domain is x and range is y. Now, you will have an activity on online, and so I'm going to walk you through what you would do with that activity, so you'll know how to do it, and then I'll show you how to get there. So here, a plane takes off and climbs steadily for 15 minutes until it reaches a peak of 35,000 feet. It travels at that altitude for 2 hours until it begins to descend to land, which takes 15 minutes at a constant rate. Draw a graph of the situation. You will do this on Holt-Reinhardt. So let me show you how you'll get there. So you'll click on, whoops, where's it? As soon as this comes up, you'll click on this link, class link, Holt-McDougall online. And then, so then you want to click on that. And then that will take you, so you'll click on Holt-McDougall online. And that will take you exactly where you need to be. And then up will pop an assignment for you. And so you will do this assignment that I'll post out on Schoology. There will be an assignment for you to do there. Okay. But it will involve a lot of what I'm doing here, so pay attention. A plane takes off and climbs steadily for 15 minutes until it reaches 35,000 feet. Okay, so here, so what you would do is you click that accent, and then you'd have to place, so then you would start at 0, and then you click, and then you would drag that line, and let's see here, for 15 minutes to 35,000 feet, and so you would drag that line, and it would create a line for you like that. Okay, a straight line. I can't quite do a straight line there, but. And then you would click travel at altitude. Let's see, it travels at that altitude for 2 hours. So you click this line here, travel at altitude, and then you would, again, you'd place a marker there, and then this is going to be for 2 hours, right? And so 120 and 15 would be 135. So you place a marker there, and then you will go all the way to 135 there. That represents 2 hours. And then until it begins descent and land, which takes 15 minutes. Okay, so, all right, so you would click the descent key, and then you'd place a marker there, and you'd go all the way down. 15 minutes would be 150 minutes. Okay. Now, if you make a mistake or whatever, you can do the eraser or whatever, but that's the way you would do that. Now, what will be my domain here? So my domain would be x is less than or equal to 150 minutes and greater than or equal to 0. Or in interval notation, it would be from 0 to 150. My range here, D represents domain and R represents range. The range, if I look at here, so it goes all the way to 35,000 feet. So it'll be y is less than or equal to 35,000 feet and greater than or equal to 0. So that will be the altitude. And then interval notation here, let me clear that up. In interval notation, that would be, so from 0 to 35,000 feet. Right? So that's how you would do that one. And this is a continuous graph. right? Time is continuous. It's not discrete. This is a continuous graph. Continuous. And then let's look at the last example here. So let's say here, a contestant on a game show is given $100 and asked 5 questions. The contestant loses $20 for every wrong answer. Draw a graph of the situation. Okay, so then what you would do, you click on 0 wrong. You click on 0 wrong, that radio button, and then if they answered 0 wrong, well, they get $100. So you would plot a point there. If they got 1 wrong, you click on that radio button. So you click on that, and then if they got 1 wrong, well, they would now have $80. 100 minus 20. If they got, and then you click on 2 wrong, and then that would be, they have $60 because they got 2 wrong. Then you click on 3 wrong, so now they would have $40 because they got 100 minus 60. And then 4 wrong, that would be $20. And then, of course, if they got all 5 wrong, then they lost an entire 100. All right. Draw a graph of this situation. Now, the domain would be a little tricky here because it's not continuous. So the domain, and I have to write this like as a in roster notation. So it would be, okay, it would be numbers like, so what would the domain be? Well, you can have anywhere from 0 to 5 wrong. So 0, 1, 2, 3, 4, 5. Roster notation. Okay, it's a discrete set. You can't have 1.5 wrong. You can't have 2.5 wrong. The domain would be roster notation. It's a discrete set. And then the range, well, you could go anywhere from $0 and by multiples of 20. So 0, 20, 40, 60, 80, and 100, meaning you didn't answer any. Okay, so again, that would be, so this would be the domain, and this would be the range. All right, domain and range. So that's how you would answer those type of questions. Some of the questions may ask you for the domain and range as well of that graph, and they may ask you for whether or not the graph is continuous or discrete. But again, you do that, the assignment will be there waiting for you. Okay, when you sign in there. All right, so that's your second assignment then for today.